Okay, let's just see. Yeah, it's recording. Thank you.
Okay.
Yeah.
So my name is Sergio Shimura. I'm third generation of Japanese immigrants in Brazil. And I'm an electronic engineer. I teach at Federal Institute of São Paulo. I teach electronics, and I'm also a researcher there.
I am Maria Lima Toivanen. Toivanen means I'm married to a Finn. I'm living in Finland already for 15 years, working at BTT, the Technical Research Center of Finland. My topics of like different subjects, but I try always to see international cooperation for tackling of societal challenges, and then I'm especially focusing on Latin America, the Caribbean regions, for more closer cultural connections, but also been working projects in Africa and Southeast Asia. And that, yeah, as I had already said, what it was the context of the interview. If you allow me, I could go straight to the questions.
Yeah, sure.
Okay. Yeah. Please describe for us, like, what is your invention or the solution that you mentioned that's already under production, and like what it is and how it is related to tackling of the COVID-19.
Before mention this, I'd like to talk about a little bit of Federal Institute.
Yes, please.
It provides free education from technical high school up to graduation and post-graduation as well. And we have several, and in the beginning of April, we had several initiatives to tackle COVID-19, such as food donation for those who are unemployed, who lost their jobs. And also we build face masks using 3D printing. And this particular product equipment we developed was pulmonary ventilator. So as soon as Tech Park here in Sorocaba knew about these initiatives of Federal Institute, they invited us to participate in a project of building a pulmonary ventilator here in Sorocaba. So we live in I live in Sorocaba, which is 100 kilometers from São Paulo, which is the capital of the state of São Paulo. So they invited us, so we had a full week work with this project, working late at night every day. And then when we finished the project, so we started to think, well, what to do next? So I knew about this University of São Paulo project. It's called Inspire, or Inspire in Portuguese. So I decided to talk to their coordinators just to exchange experience and then how to manage and go to the next phase. So after we had a meeting, and after we present our developments, they showed theirs to us. And then it was clear that was missing several things in our project. It was very in the early stages. And then looking at their project, they were more developed. They had more backup information. So they invited us to participate in their projects. So basically this device is a pulmonary ventilator. The main purpose is to use in emergency situations, but is able to use it even in intensive care units. So from the emergency situations in ambulances, shopping malls, for instance, or soccer fields, up to intensive care units. So it has a lot of features that makes able to work in different conditions.
Then did it become one project alone when you
Yes, just
you
one
associate
project,
with,
yes.
yeah, with the University of São Paulo.
Yes, we put aside the project we were working in Sorocaba, and then we started to collaborate in this University of São Paulo product.
Yeah. Can you please talk about the features of this pulmonary ventilator that you are developing with them?
Yes, the main feature is that it's a local development. So this is a very important thing. So regarding production, maintenance, procuring parts, these are also being thought about before. It was one of the requirements of this device. So it makes it easier to produce and easier to obtain parts. And also it uses the main unit to generate compressed air is the EMBU, the airbag. Probably you've seen in the TV and news. It's a bag. So this is the main thing. So it can be used for this reason. It can be used in ambulances. I mean, in every place that's outside intensive care units.
So it is kind of like a mobile, robust kind of thing, in a sense.
Yes, that was the idea.
Okay, yes.
Besides having this very simple approach, it also has very sophisticated features, such as it keeps pressure, it controls pressure, controls volume, and has all the features of high, better or
expensive,
yes, more expensive units, yes, like VCV, PSV, PCV as well. All these modes of operation.
Yep. And would you like to add about the motivations to create this besides the partnership with the city of Sorocaba and the University of São Paulo? Was there any other motivations for the university?
Oh yes, several. Yes.
Yes.
I would say this one was very important that you mentioned. This partnership is something that will last for other projects in the future. Regarding the motivations, I would say that the one you mentioned is very important. The partnership between Sorocaba campus and University of São Paulo will be something that will last for other projects as well in the future. And also I'm an electronic engineer. So in this project, there's a lot of electronics, embedded electronics. So I really like to work with this kind of projects. Of course, helping to tackle COVID-19. This was, and helping save lives. This is a very important motivation as well.
Can you please also talk about like the institutional context where this solution is has been developed? I mean, like, what are the situation there in Brazil that justified to try to produce a cheaper pulmonary ventilator, and also like if this could be deployed in other places, and how?
Oh yeah, sure. Regarding costs, this device that we costs about less than $1,000, would be roughly about $800 approximately. So comparing to what the governments and hospitals pays for this type of device, they pay for a commercial unit about 100,000 reais, or about 20,000 US dollars, up to 500,000, which is $100,000. So it's a very, very expensive equipment. So, and also our government federal government. We have election by the end of 2018. The term started in beginning of 2019. So in the beginning of the pandemic, the authorities they did not. They were not very serious about this disease. They are favorable to open all the commerce back. They were not favorable to social isolation. But fortunately, every state was able to do their own policies regarding the pandemic. So we were not so bad in this about tackling the COVID-19. But today we're reaching about 1,000 daily. So it's becoming a very worry situation for us because it already passed the peak, but it's still at the very high, with these very high death rates. We have about 3 million cases and 100,000 deaths in Brazil.
Yeah. And have you known about other projects like this in other countries or other organizations?
Yes, as I mentioned before, there were several sparse initiatives in Brazil. Many institutions, startups were developing this kind of ventilator. But as far as I know, it is the first bamboo-powered ventilator to be approved by Anvisa in Brazil. Anvisa is our local agency for and medical equipment.
Yep. Okay, this is also an important aspect about the regulation of the equipment.
Yes.
The like acceptance according to standards and so on. Can you describe a little bit how is this process of getting the certification and making it appropriate, and also in this context, it has been already tried out in human beings, and how it has been speed up the approval, and how you got it?
Yes, due to the pandemic, Anvisa issued different procedure, easier procedure to register new equipments. But even though we had to pass through a lot of tests, and it was very difficult, and we had to spend a lot of time, basically. So the equipment was tested in animals, and also in humans by April. And then we had another, for the first batch was beginning of approximately, we had 10 units. So they were used in tests in the University Hospital, the Hospital das Clínicas in São Paulo. And it was a successful test there. And last month we had a test in IPT, the Technological Institute of, they issue reports for Anvisa, the technical reports. So we passed the electric discharge test, electric conductance test, and radiation test as well. So there's a lot of things that we had to go through to have this this equipment approved. So it's a very intense and time-consuming, I would say, because there are a lot of reports that have to be made, and and tests that have to pass as well.
Yeah, and this is also sorry, now I just missed the word, but it's like you are not claiming intellectual property rights.
So open source kind of.
It's open source, yes.
Yes, yes. It's going to be an open source. The main idea of this project is, in the end, to have store those designs and open to the public, so it can be used to other companies can produce them. That's the idea.
Yeah. Okay. And how this pulmonary ventilator that you are producing, how it differs, like besides the price, but in terms of features, how it differs from this, let's say, one of the conventional brand solutions that are being sold in the market now?
I would say there are two features that are very important. One is that uses local knowledge, local technology, so it makes it easier to make modifications, upgrades, and maintenance and production. It's much easier when you have a local technology. So this is something we lost over the years. We are very dependent for outside technologies. So this is something that is very important in this project. The other thing is it uses the EMBU, the airbag unit, so it doesn't need to compress air. So it can be used in emergency situations with very easy. It's a very easy approach to use this equipment. Yeah. These are the two main reasons.
Yeah, you mentioned this EMBU. Just to make sure I'm taking, is this company that produces these like single-use devices, or this healthcare company?
Oh, EMBU is a generic name.
Yes, yeah.
Yes,
then they produce different health devices, but I understood that they are mostly focused on like single-use devices that you just then after.
Yes.
Okay.
This is the purpose is to be squeezed by hand. So what we did is a mechanical automatic equipment to do this in a controlled way.
Yeah. Okay. And what changed in product design and development were needed to make it this ventilator more affordable?
In the beginning, we were using materials such as acrylic to make the structure, so it proved to be not very useful for production. For mass production, we're now using aluminum to build the structure, overall structure, and also we're using there are some most of the parts are off the shelf, but the parts that are unique to this equipment, they were made with a very intelligent and easy design. What I mean is that it's very cheap to produce them. Also, we can produce with 3D printing as well. So these are the changes we made for production and made them affordable.
So yeah, so somebody, for example, somewhere in Nigeria or India or South Africa or wherever they are, so if you put it as an open source, they could take this specification sheet and then they could come up with kind of like prototyping and rapid manufacturing, so on and so forth, type of things.
Yes. Yeah. Yes. What we used to produce the first prototypes was basically 3D printers and laser cutting machines. So we can use plastics like we did in the beginning using acrylic. It's not very good for mass production, but for a local fab lab can make it, yes.
Okay, that's quite an interesting approach.
And also regarding the electronics, the first prototypes were made using Arduino platform.
Okay, excellent. So something like a Raspberry or Arduino or one of those like relatively cheaper parts. Okay.
Yes, very cheap and
too,
very easy to obtain.
Yeah.
Okay.
And what about the resources to produce this ventilator? How they were acquired?
There are two types of things that the team were doing. First, regarding financials is the fundraising. We had crowdfunding. The coordinators of this project made a crowdfunding, so it get donations from banks and institutions, the industry, the industries of São Paulo, of this region, also donate money for this, to make this project to make it possible. And also there were a lot of volunteers working on this, research volunteers, and also from the institute I invited one professor and one student to help with the programming. So we had financial and also donation forms of volunteer work, and also components to build.
Yeah, and now for the production, how are you going to finance it?
Donation is the most important, the main way to make it viable. And also we have the Navy of Brazil working in manufacturing. So we have they have a facility very close to the labs. So basically, when I go to São Paulo, I probably go today and this whole week working with this project. I'm working with the manufacturing, so I spend half of the day in the lab, Universidade of São Paulo lab, and also in the manufacturing plant at the Navy in São Paulo.
Okay, this partnership with the Navy is then the main aspect that helps to produce, like to manufacture in a bigger scale of the.
Yes, at first we may think that is a very strange partnership with the Navy, but they have a very sensitive researchers being conducted at this lab in São Paulo, like nuclear submarine. So they are very used to deal with high sensitive equipments and very critical processes. So to get the Anvisa registration certification, this one of the most important aspects to have was to have Navy as our partnership for manufacturing.
Okay. Then would you then like we see that like having trustworthy partner, also not only in terms of the quality of the work, but also the quality of installations and so on, as the Navy. To find this one was potentially a challenge for the project, if you agree. And then also,
yes.
Could you talk about other challenges that you are faced for the production of this ventilator?
I was not very involved in the manufacturing side or the high level decisions, but I knew that other partners were. So regarding manufacturing, other companies such as Flextronics, Foxconn, the operation, but it wasn't a very easy approach. I don't know exactly what the reasons were, but the Navy has a lab very close to the University of São Paulo lab where this equipment is being developed. So it makes it easier to interact with the Navy. And also because they have all this expertise in sensitive production, it was it was easier to get the certification from Anvisa because they already have all these quality and security procedures in place.
And this ventilator is being distributed only for hospital and other organizations in the state of São Paulo or in other places in Brazil?
In the beginning, we built 10 units. They were all sent to Hospital das Clínicas, which is the University Hospital of University of São Paulo. And now we're making 30 units. I know that about 5 will go to northeast of São Paulo, of Brazil, I'm sorry, and also Rio de Janeiro. So by end of October, we'll probably have 500 units.
Okay.
This is the schedule.
Yes. And how are they being produced? Or the planned? Is all by the Navy?
Yes, all by the Navy until end of October. 500 units, and they will be all sent to all the states of Brazil.
Yeah. And would it be possible, for example, like as we mentioned before, that being open code, that other organizations be interested to produce them and still get the certification by Anvisa?
Yes, they will have to go through all the tests and audits. It's not only the tests to go through audits, also the manufacturing process, quality controls, and everything. So it's very time-consuming process.
Then it might be easier if just the Navy that has already the certification continues producing.
Yes, until end of October, the initial plan is to have 500 units, but from that day on, there is no plan at this moment. But probably they will make more, and also will be producing the ventilator, hopefully.
Yeah. And what would be needed to make this solution more scalable? Like we see that to have a manufacturer that has the right capacity and also goes through the tests, but are there other ways that we could think of speeding up the scalability of the production?
Well, I would say that we now have production capacity of 10 units. This is the goal, and this is what we aim for. But the bottleneck of the production is not the making or building the unit itself. It's going through the tests and calibration. To build one unit, we take about 3 to 4 hours, maybe. During normal production, probably will take much less than this, probably 1 or maybe 1 hour to build one complete unit.
Yeah, by robot.
But the problem, no manual production, mostly. But probably, what takes a lot of time is calibration and tests. This is the bottleneck of the production. That's why we build only 10 per day, because the tests takes about 2 hours approximately. So it uses special equipment. So usually at the Navy, we only have one of these calibration units. So it's very expensive and not very easy to obtain. It's a artificial lung, so it must measure volume and flow of air with very high precision. So it's a very so it takes a lot of time to calibrate one unit. This is the bottleneck of production. So to speed up, we certainly need to have more of these equipment and more partners doing tests and calibration.
Yeah. Have you had any discussion about transferring this technology to other countries?
Main discussions about this project is to make this design for open to whoever wants to build this equipment in other countries as well. But the problem is to get the approval from the agencies. So it's a process. Maybe the best way to deal with this is to make the Navy production or other partners already this approval from the agency.
Yeah.
To start building. But for other countries, I think this will not.
We don't hear you. Hello?
Oh, sorry. Hello?
Yeah, you were saying for other countries, what would be needed?
No, for other countries, since the is outside our agency, so this will not be a issue for them. Maybe local is needed. They will have to go through this anyway.
Yeah, with their own agencies and local regulations.
Yes.
Yeah,
and also the open source of the project will help with respect to I guess.
Yeah, should.
Yeah.
And have you been involved besides the 3D printed face masks that you mentioned? Have you been involved in other in development of other solutions to address these contextual challenges? And I'm not meaning only in the case of COVID, but in other activities trying to produce cheaper, affordable, and more accessible solutions.
Oh yes, not specifically for the COVID-19, but we have a group of researchers working with autism and also people with mobility issues. We're working now with automation of wheelchairs, a wearable electronics for autism. So this is the project where accessibility for us is a very important line of research.
Okay. Well, from the list of questions that we had prepared, we got to the end of it. Venkata, would you like to make any questions?
I was just thinking a few minutes ago, there was this conversation about the calibration, and that is like a bit time consuming.
Yes.
I was wondering, so I think one of the things you said was getting more resources so that the calibration can be done faster. So I was thinking, is this an issue particular to this equipment, or this calibration taking a long time is an issue faced by all kinds of ventilator manufacturers?
I'm not very familiar with the other processes regarding. I would assume that it's the same process. Yes.
Okay. So this
Because
is a
we
generic
have to
bottleneck
make sure that the flow is measured correctly.
Yeah.
I believe so. Yes.
Yeah. So that was a clarification I needed. Yes. Thanks.
Would you like to add any comment regarding the topic, Professor?
Oh yes. Oh, I'd like to thank for inviting me for this talk, and also it was a pleasure to work with the University of São Paulo. They're very skilled in high-level researchers. So that for us, the Federal Institute was a very rich experience. So,
this is definitely very good to hear. And as a Brazilian, I feel especially proud. And our plan now is go on with some more interviews and the writing of the paper and the presentation in November. And I will send you when we get the invitation for this online workshop. I will share it with you.
Please.
Well. Yeah.
Okay, please.
Yes,
Thank you very much.
To do that. And also when
I'll be very happy to.
Yeah, and then when we have also written the paper, I would like to have your comments and so, if you allow us.
Thank you very much.
Yes.
Yes, thank you very much for your time, Professor Sergio Shimura. Yeah.
And we wish you very nice.
Thank you very much, Venkata.
Yeah, we wish you very nice continuation of your day there. And how is the weather in Sorocaba?
Oh, it's mild, not very cold, not very hot. Sorocaba usually is very sunny city.
Yes.
So it's a very pleasant here.